Okay, in this video, we are going to talk about how to convert from rectangular to polar coordinates and how to compute double integrals. All right, and this is what's called a polar rectangle. Okay, so let me explain how to set up the limits of integration. So the original limit would be 8x, right? And then dA just means it's like dy dx or dx dy, which is an element of the area. So when they don't know which way, they just say dA. All right, but either way, we have to switch to polar coordinates. So how are we going to do that? Okay, so here we're going to have dr d theta. So the first thing you need to do is determine what about your limits. And the way you do the limits is you're going to look at your region and first fix theta, right? And so fix this theta. Um, so that it's going to be like, let's say you start over here and this is your fixed angle. How does your distance to the origin change provided you are inside this blue region, right? So I think what's going to happen is if you're over here, right, that's how your R is going to change. You're moving along, and then when you're on the boundary, your R will be 9, and when you're over here, your R is 4. So R, which is going to be your inside limits, right, because this is R, these are R limits. So that's going to be from 4 to 9. But what about theta? So theta is the angle with the x-axis, and because it has to be from smaller to larger, I think what we're going to do is just look at negative pi over 2 all the way to the top at pi over 2, right? So let's try that and see, because sometimes they also would be okay with another, like if you were to add 2 pi, but I don't think that's the case here. So this is not going to be 0, sorry, so that's going to be 4 to 9. So let's at least check that the limits are correct. Okay, so next what you need to do is change the 8x that was in here to polar coordinates. Now here are the connections between the rectangular and polar coordinates. If you see x squared plus y squared, you are immediately changing that to r squared. But we don't see that. We actually see 8x, right? And we need to transform that to polar. So that's not really going to help us. But we also know that x is r cosine theta and y is r sine theta. So that's going to help because instead of x, we're going to put 8 r cosine theta. Now, you would be done at this point, except when you are switching from one set of coordinates to another, there is something called Jacobian, okay, that shows up, which is like, what the heck? But it's really not that simple. You need some other term, and that's called the Jacobian. And in the case when you're switching from rectangular to polar, the Jacobian is just equal to r. So I always tell my students to remember this as what the pirate says. So the pirate says R. So you remember when you're switching from rectangular to polar coordinates, you should never forget the pirate. And the pirate says R. And this R doesn't seem to come from anywhere, but it's because you're switching to new coordinates. Okay. And by the way, where this comes from is when you take this R cosine theta, r sine theta, and start doing partial derivatives. Like with respect to r, this will be cosine theta, right? Because derivative of r is 1. This would be like r sine theta and minus, that would be the derivative with respect to theta. And then over here with respect to r, that would be sine theta. And this one with respect to theta would be r cosine theta. And if you find this determinant, remember you multiply this way. So you get r cosine squared theta. And then you subtract the product of the other two like this way, but because this is a minus, that'll be a plus. And so you'll see that that would be r sine squared theta. And you can factor r, and you'll get cosine squared theta plus sine squared theta. And that's where you get that Jacobian, that pirate thing, r. Okay, so that's just a proof of it, but you know, you don't need to know this because I'm not going to ask you. So if it was like a theoretical course, I would definitely talk about change of variables and all that, and we're not doing that. Okay, so instead we're gonna just go ahead and integrate something like this, and the limits are numbers. Now, why I love polar coordinates is because you can actually a lot of times split the integral. So when can you split it? Okay, so let's go ahead and talk about that, because I like to, instead of integrating double, I'm just going to integrate two single integrals and then multiply the results. So this is going to be 8r squared. That's because this r and this other r combined is r squared. And then cosine theta dr d theta. Okay, this d does not look good. All right, so why can we split here? So whenever you have a product of just the r and just the theta, and then also the limits are numbers, so the limits cannot have variables. If that happens, then you can split the integral in just the theta part. So this is going to be cosine theta. Multiply that by just the r part. Okay, and that's going to be 8r squared, and r changes from 4 to 9. And then you just multiply the results. Okay, so hold on, let me just type that r squared cosine theta in here. So now we just have to evaluate this integral, which is supposed to be really easy because cosine theta is sine theta when you integrate. Changing from negative pi over 2 to positive pi over 2, multiply that by 8, and then 1/3 r cubed, right? That's the rule, is when you add 1, and then you divide by the same thing, that's in the power. And then we're going to substitute 9 and 4. Okay, so partially I will do this on the calculator. So if I want to find 8/3 r cubed when r is 9, and then subtract 8/3 r cubed when r is 4, I'll get some huge ugly fraction. So this is something 5,320 over 3. What happens to the other guy? Well, sine at pi over 2 is 1, and sine at negative pi over 2 is -1. So this is actually going to become, I think, 2. So you just have to double this result. So 2 times 5,320, so that's 10,640 over 3. Now, by the way, if you don't believe me, you can switch to radians. Make sure that the calculator is in radians and say, what is sine of pi over 2? Okay, 1. What is sine of negative pi over 2? Okay, -1. So that just confirms what I got. So let's see if that's right.